Hi, hello. We are going to the task 8.2 demonstration and presentation. So, the basic idea of a project is having a smart toilet where whenever the people enters into the room, the light turns automatically, and whenever they leaves out, the light turns off automatically. And it also has a special feature where it detects the natural light as well as the normal light which is present in the bathroom. A sound sensor is also placed near the commode so that it detects the flush sound and automatically turns on the exhaust fan, as well as the this perfume, which is we can call it as an air freshener present inside the toilet. So the primary equipment we used in this project is Arduino, motion sensor, LDR sensor, sound sensor. The Arduino is the main system of the main this center of the system. Like it only makes to run the code at the background and collects the data. We used motion sensor to detect the motion of a person whenever a person is entering the room, and then LDR sensor. We use this for and detecting the natural light and differentiating the natural light with respect to the normal light which is emitted by the bulb in the restroom. Sound sensor. As I said earlier, it is used to detect the flush sound and release the air freshener, as well as the turning on the exhaust fan. And next we goes to prototype. Here's our prototype in the left side of the image. As we can see that there are two main chips. One is the Arduino and other one is an extension which connects to the motion's LDR sensor. And above that we can see a white big plate. So it is a resistor. Sorry, it is a resistor, and it resistor connects the microscopic sound sensor as well as the fan as well as the LED bulb. So as the whole setup I can explain you, we have done this using a cardboard box, and we used male and female jumpers to get connected with every each sensors with the Arduino. So here how it works. So whenever a person comes inside the restroom, he enters the doorway, where upon that there will be a motion sensor, and left of him there will be a light. So whenever he comes, he uses the washroom. So when he uses the washroom, if he flushes it, then the next to the flush there's a microscopic sensor where it detects the flush and allows and sends an immediate code to motor, a motor fan, exhaust fan, as well as the air freshener which is located next to the motion sensor, so that it removes all the bad foul smell inside the restroom. As we can go forward, this is only a prototype, a basic simple prototype at the smart restroom. So I can conclude saying that how it is beneficial for the users. So what this question explains why we made this actually. So as we can see in the task sheet given, that we need to make a project, develop a project which is very helpful for mankind and which makes very smart for them and easy. So as we can see that many people are wasting the electricity only by turning off their lights. Like whenever they use the toilets for for getting in, they'll use it and they'll forget to get off it when they're returning back. Whereas we use this motion sensor to detect when there's a motion, as well as LDR to turn on and off the light. So in this way, electricity will be saved as much as we can. And we also used LDR. The reason behind the LDR was to detect and differentiate the natural light as well as the common light present inside the room, so that whenever the natural light is present, there need not to be using of any electricity inside the room. So in this way we can also save the electricity. Last but not the least, this idea, the sound sensor idea, why we use is to help mankind more simple, to make his life more simple. Like he need not even stress about getting off his bad smell. So for this, whenever he uses one single sound, flush sound, it automatically sound sensor will automatically detects and takes out all the foul smell. So that whenever the next person uses the washroom, it will be beneficial for him as well as it will be beneficial person who is using it without doing any work actually. So I conclude myself for my demonstration and presentation. We have demonstrated this task to the tutor, and thank you for giving this opportunity.
So this is a code for my complete that concept of smart restroom. We prepared this code for that. So I connected, these are the pins which I connected to. I connected LED pin which was for motion sensor and LDR sensor connected collectively. So and the other one was LDR pin which was connected to analog pin 5, and then there was sound sensor which was connected to digital pin 5, and this LED for sound sensor that was connected to digital pin 4. So moving in this white setup, I have declared serial begin for serial monitor, and then I declared the input as digital pin 7 for motion sensor, and then input as LDR pin for LDR, which is LDR pin is declared over here as A5. So I declared basically that indirectly I declared that A5 as an input pin for LDR, and for LED pin I declared 12 digital pin 12 as output for motion and LDR, as you can see that in the comment. And then there is sound sensor. I declared sound sensor which is digital pin 5 as input, and then output is LED which is digital pin 4. So moving forward, now there's a main code over here. I put a conditions over here to work my code properly so that my code can work properly. So I declared the integer, the variable integer LDR status is equal to analog read, and so it will read the value analog value from the digital analog pin 5. So here's the code. If motion sensor, the digital read 7 is motion sensor actually. If motion sensor is high and LDR sensor, LDR status is less than 200. So what 200 is over here is like it's like proportional to light intensity. So as this LDR status value increases, light intensity increases. As it decreases, light intensity decreases. So normally 200 normally the value of like light intensity of 200 is enough for light not to is enough for artificial light not to be present in the room when the light intensity is equal to 200 or more than that. So I've made code accordingly to that. So once the conditions meet when motion sensor is high and the LDR status less than 200, so it will print active as motion sensor will be active, and then it will turn the LED pin for motion sensor and LDR sensor high, and then there's a delay of 5000 seconds. The delay of 5000 seconds means that LED pin will once it's turned on, it will kept in that manner for at least 5 seconds. That's what the delay is used for over here. So we can change that time to keep that turn on for like, if you want to keep it turned on for 10 seconds, we can change it to over here, like instead of 5000 we can put 10,000 over here. And there's a serial print value which will demonstrate, like which will tell the situation of that particular room. So it's dark and light should turn on as there's motion. as as we know that it's less than 200, so it will show as dark, and there should be light turning on after that. So light should turn on as there will be motion is there, motion is active in it. Similarly, there's a condition over here as well. Digital pin read 7, like there's a opposite condition to written over there, opposite to the condition which was written on the top of it. So is, as you can see that LDR status like greater than or equals to 200. So the it's already bright in the room. The light is good enough, so no need to turn on the LED. So the LED will stay low, and it will show that this statement is bright. No need to turn artificial light. Although the motion sensor is active. So the next condition is when motion sensor is low and LDR is greater than 200. So it will show inactive, and it will show this line as well. It's bright, turn off the LED. This is the one. And it will keep the LED low similarly. And the last one is similar to the previous one as well. It has no motion present over there. Once the no motion is over there, it will show inactive, and it will show this status when the LDR status less than 200 and at the same time motion sensor is low. So moving further, this is sensor data. I've declared sensor data as digital read. It will read the value from digital read pin 5, I guess. Yeah, it's pin 5, digital read pin 5. And if the sensor data, if digital read pin 5 is equal to 1, then only this statement will go further on. Okay, so then let's give a condition of boolean status, boolean condition, and then I'll turn the status to true, and then the LED will turn on if the sensor data is equal to 1 and the LED status is equal, LED is not blinking, and it will show this sound detected from flush. It will print this value on the serial print as well. Hence, otherwise it will turn the LED off, and it will set the LED status as false. And this is what it is from my side. That's a code for our concept of smart restroom.